Welcome to all, class number 95. As I told last time, see a question or simply support beam with uniformly varying load, either end 0, in between maximum. This was solved long back in class number 69 and 73. But at that time, it was maximum at center. Two standard cases, see one this way and one more this way. See, you can see here this way and other one is this way. Book work and numerical both are solved. Then I have not considered the question where maximum is not center, somewhere else. Recently I remembered. So as I told you, this course will cover the concept completely, nothing will be left out. So I will include this question now. Today I wrote 3 concept based questions. And remember, by going through all these 3 questions, you will get further and further more knowledge. Uniformly varying load will become more easy for you. See, I wrote all the question here. See, question 1 is, all 3 questions are, if you want words, simply support beam of span 12 meter, loaded by uniformly varying load, intensity 0 at ends and maximum of 90 kN per meter. For the first question right at center, second question right at 4 meters from left end, third question right at 9 meters from left end or 3 meters from right end. Draw SFD BMD. Okay, now this already solved earlier, but still I want to include it. So too much I will not tell because you can refer class 69 and 73 and get more idea, but still briefly I will tell. And I will maintain everything here. These are actually somewhat practice questions, but I will inform or write important concept. So what all I want to write, I will use the space here, which is already known for you, which you have got full control, you should write. I will dictate here, but important portion I will write here. Okay, start. First, I will first do one thing, all 3 questions, but you should do one thing. See, I will finish reactions for 1, 2 and 3, then I will start SFD BMD. You should, if you want perfect knowledge, start question 1, find reactions, draw the diagram, finish everything, then go to question 2. Okay, that way I should write fair copy. Okay, start. Question 1, reactions. VA equal to VB. Symmetry is there. So, therefore, no need of applying sigma M0, sigma V0. Directly apply VA equal to VB equal to total load on the beam divided by 2. Total load equal to half into 12 into 90. Divide by 2, each reaction will come 270 kilonewton. That is question number 1. See, applying sigma M0 and sigma V0, there is going to be a tricky question little later. Maybe class number after 100, I told century class, I will give clarification. Same class end, I will ask a beautiful tricky question. I want to know how many can answer it. It is really mind twisting. I would like to know later how many are going to answer it. Okay. Now, first question, reactions over. So later, question 1 continued here. Sometimes see what happens when I write here, when I touch a little portion goes off, don't make issue of those things all. Okay. Question 2. You already know how to find reaction. Still I will explain. Here you cannot write VA equal to VB equal to total load by 2. Why? Unsymmetrical. Therefore, take moment about A. See, minus VB into 12. This question also 12. Plus half into 4 into 90 into 2/3 of 4. That is moment of this side. Again plus half into 8 into 90 into 4 plus 1/3 of 8. That way write and get the answer. This question, same way, half into 9 into 90 into 2/3 of 9. Again, half into 3 into 90 into 9 plus 1/3 of 3 equal to 0. Get the reactions. I will calculate the reactions here. So, but if you know a trick or formula, you need not consider the 2 sides separately. Single side you can consider. Because if you consider entire loading, I told long back, if you consider the entire loading also, single stretch, resultant will pass at from here L plus A by 3 or L plus 4 by 3 from here From there, L plus 8 by 3. If you know it, okay, but better for you, do separately. But when I find reaction, I don't require this cut calculation. I can do directly. So this will be equal to half into 12 into 90 into 12 plus 4 divided by 3. That's all. Divided by 12. I got 240 kilonewton VB. One nimisha. Okay. I got VB here 240 kilonewton. Then minus 540 will come 520 kilonewton VA. VA will come 520 kilonewton. See, if you add these two, 520 plus 240 will be 760. No. Oh, not 520. I think I not calculate total load correctly. Total load is half into 12 into 90. Okay. 540 minus 240 will give you 300. See, I can make out. If something goes wrong, immediately I can make out. 300 kilonewton. Now see, here, total load is equally transferred to towards support here. Since the intensity is more this side, more force will come here, less or more reaction here, lesser reaction there. This question, more reaction will come there, less reaction will come there. I will calculate same way that reaction also. Half into, how much it is? 12 into 90 into 12 plus 9 is 12 plus 9 divided by 3 is equal to how much? Divided by 12. You never do these things all. This will come 315 kilonewton. See, major reaction here. Minus 540. This will come 225 kilonewton here. Okay, this all you calculate correctly and get the reaction. Now, support reactions are fully covered. One nimisha. 340. Correct. Okay. Now, be little careful. Why careful? Because SFD BMD you require. See, first remember, I will tell only once. All three questions. SF variation, A to C parabola, C to B parabola, different parabolas, second degree. All three questions. Why? UVL. BM variation, A to C and C to B for all three questions are parabola of third degree. These all you have to write as usual. Where to write, how to write, class number 95. You know where I used to write. After showing SF calculation, then when you are going for a diagram, then I write it. After doing all BM calculation, when you are going for diagram, then I write the statement. You write at the applicable time. Over. Now, here, start. SF calculation. SF calculation, you do it. See, go up by 270. Then, from here to here, come down by this much load. Half into 6 into 90. Exactly 270. 0 will come. Again come down by half into 6 into 90 minus 270. Now, parabola of second degree. But remember now, here if I draw a tangent, it should be a common tangent for both. Slope should be same because why? Same intensity. And here, 0 intensity, maximum intensity. 0 slope, maximum slope. Here also, 0 slope, maximum slope. Or from here to here, slope will reduce 0. Over. Now, lastly, BM calculation. BM at A 0, BM at B 0. Okay. Come to BM at C. Look this side. One thing, forgotten. Location of the point where shear force is 0 is not there because you know shear force is 0, exactly center. Therefore, the center itself is the point of maximum BM. Already over in class number 69-70. Now, calculate BM. BM at A 0, BM at B 0, BM at C. Look this side. You should calculate. I am not explaining why. How many times to be told? Plus 270 into 6 minus half into 6 into 90 is the total load into 1/3 of 6 will give the BM at center. That will come 270 into 6 minus half into 6 into 90 into 1/3 of 6 will give you 1080. I already calculated because if it is this case, there is direct formula also is there. WL square by 12 is the maximum BM. WL by 4 is the reaction. If you want, you can remember long back told. See the bookwork. Anyway, today you don't go for any formula. You do basic calculation. Over. Now, BM over see, parabola of 30 degree plus 0, 0. This is a maximum BM point. So I put a tangent here. 0 slope should be there. Red color means maximum BM. Exactly here. Here. Over. Question 1 completely over. 1 minute now. I'll check the camera. Okay. Sometimes what happens is little wire pulled means if it goes side, then you cannot see calculation written here. Okay, now start. Second question. First, shear force calculation. I will dictate here. You write. Shear force at A, slightly come inside, plus 300. Shear force at C, plus 300 minus half into 4 into 90. You calculate. Then, shear force just at B, slightly this side. Whatever you got at C, minus half into 8 into 90, get the value. So, at A, you got. Here also same calculation, 0. Jet to left, no jet to left, jet to right. It is not point load. Shear force at A plus 225, shear force at C plus 225 minus half into 9 into 90, and then here subtract this load. This all already over. Now what will happen is, here when you find shear force, you will get positive. When you find shear force here, you will get negative. Here it became 0. The symmetrical case. Anyway, you can also draw shear force diagram without showing calculation. Do it now. Take your calculator. Here, see. Go up by 300. Okay, so to some scale. Don't compare the scale of these two questions. I cannot maintain scale here. Independent question. Sometimes people will tell, if I write 300 here, sir, this is 270 bigger. I will tell which question? Don't compare that question with this question. In this question, if I write 300 this way and 240 this way, then you tell, sir, what about scale? Then agreed. Not for other questions. Yesterday's question, previous questions, you should not compare scale for this one. See. Okay, now start. Go up by 300. See, slightly skipped here. See, little slip means we don't know. Okay, projection is wrong here. See, it will come here. That's why I am getting difficult. Okay. Go up by 300. Available space, I will go here. 300. Then from here to here, come down by half into 4 into 90. Take your calculator. So 300 minus half into 4 into 90 will give you plus 120. So when you reach here, still you have got a positive value 120. 3.5 is 150. Okay, somewhere reasonably here, 120 is a shear force here. Okay, then from therefore, how to come now? Here to here, come down parabolic variation, and I told you 0 slope here, maximum slope here, because 0 intensity, maximum intensity. So what will happen now? See, it will become, here slope will be 0. Okay, it will come this way. Okay, now, somewhat okay, reasonably okay. Now I won't change further. Little this way should come this way. Okay, no problem. Why should you? Okay, now reasonably okay. Then, after this point to this point, again come down by half into 8 into 90. Why calculate? It will come 240 here. 240 here. This is 120. Double of 120 is 240. It may come somewhere up to here. See? 240. And from here to here, when you draw maximum slope here, 0 slope here, and both the sides slope should be same here, 90. So now onwards, the curve pattern will change. See, it will come this way. Okay, now I will draw as neat as possible. I should have drawn it earlier. See, it will come here, then onwards. See, the same curvature, it will come this way, and this way it will come. Okay, but here, when you reach here, slope should be 0. Okay, slope is 0. Go up by how much? Once again, 240 up. Okay, reasonably okay. Now, see, if I draw tangent here for both, it should be common tangent. So it will actually it will come how? See, it will come this way. So one common tangent there. So draw as much as possible. If I try to make more smooth, okay. See the curvature change here. Okay. Curvature. See here this way, here this way. Now this is the point where shear force is 0. So that point you require, let it be x. And now we want to locate that point x. Don't do from this side. Why? You get triangle and trapezium. See, if I want to locate that point, look that side. So this will be x. x. I want that value now. Okay, now 120, reasonably okay diagram. 1 minute now. Okay, reasonably okay. People will be there to comment. Let them comment. Okay. Now, see, I'll tell you this question, location of x. Location of point x. I'll explain here to you. Let the point x be at small x from right side. See, the x point will be somewhere here. At small x from right side. Okay, then let the intensity there be w suffix x. Then, just to understand, you write sketch here. See, this is the diagram. This is 90 kilonewton per meter. This reaction is 240 kilonewton. And then this length is how much? This length you can see there only, 8 meter. We want somewhere here, there's a point x at x from here, where intensity is w suffix x. Okay, now, first you get w suffix x equal to, I will not write here, 90 divided by 8 equal to w suffix x by x. So this will become 90 by 8 into x. I don't know how many times I explained. Okay, now, right, shear force at x equal to, look now how to locate x. Equate the shear, you see, I have seen in some places, sometimes people write this side by this side equal this side by this side. Utter nonsense. Why? It is not linear, it is parabolic. You have to locate the point x by equating shear force here equal to 0. So shear force here equal to, look that side. When you look that side, sign I am not writing. Class number 95. Right side upward is negative. So minus 240 plus half into x into 90 by 8 into x is the shear force. Equate to 0, you get the value of x. As you get the value of x, immediately get w suffix x also. Okay, I'll get the value now. It will 1 minute. Check the display, camera display. Okay, no problem. Because worried, sometime it happened after finishing the class, when I see their camera got tilted. Okay, now 240 into 2 divided by 240 into 240 will go this side. So it is 240 into 2 divided by 90 into 8 equal to root of that answer equal to 6.53197 meter. I will take third decimal or fourth decimal. 6.53197 is 5320. 6.5320 meter. 6.5320 meter. Substitute that in this equation, your w suffix x will come 90 divided by 8 into 6.5320 will give you 73.485. 73.485 kilonewton per meter. Now, enter here equal to 73.485 kilonewton per meter, and x you got how much? 6.532 meter. No, it has not come. I should re-enter it. 6.532 meter. I should enter once again because it went outside. X equal to 6.532 meter. What to do? Such things I have to take care. Okay, now okay. Yes, we got the value. Now, for this question, go for BM calculation. Start. Some of them I am not writing. BM at A, 0. BM at B, 0. BM at C required. This I am not writing. I will explain. See, BM at C. Plus 300 into 4 minus half into 4 into 90 is the total load into 1/3 of 4. Or, if you look this side, plus 240 into 8 minus half into 8 into 90 into 1/3 of 8. You see whichever side you want, my guarantee, answer will come same. You should write and get the answer. 300 into 4 minus half into 4 into 90 into 1/3 of 4. 960 kilonewton meter. Where is it? So when I go for BM calculation there, see, I will remove this one now. BM at A and B both are 0. At C, how much I told just now? I explained 960. Yes, 960 kilonewton meter. Okay, just now I told. Now, lastly, also you require BM at X. That I will show the calculation for you. Start. I write here. BM at X equal to, for that question. Also, BM at X equal to, see here, plus 240 into, next question I am not explaining, sorry, next question I am not writing, you should write. Why? Only change is what? X from left side. I will dictate here. Plus 240 into 6.532 minus half into 6.532, okay, red color is not required, 6.532 into, this height is 73.485 is the total load. See once again, 240 into this resistance minus moment of this triangular load, half into this X into this ordinate into 1/3 of 6.532. Calculate that BM. Next question you have to work out. 240 into 6.532 minus half into 6.532 into 73.485 into 6.532 divided by 3. 1045.116. 1045.116 plus 1045.116 kilonewton meter. Okay, now lastly, draw BMD. Statement you have to write. Parabolic variation, second degree, third degree, all you have to write. Now see, this is the standard point, C. This is X. At C you got BM, how much? 960. But at X here 960. At the point X we got little higher, how much? 1045, not too much more. 960 means, see, around this much. That's all. Furthermore not required. 1045.116. Now how to draw? A to C parabola of third degree. Simply draw it here. See, this side slope will be 300 here. Here, from here to here, see here, shear force is same for both sides. Same way tangent. It will continue, but tangent will be same for both. But it will reach the, it's a red color. It will reach the, go its way, reach the peak value, and then it will come this way. Okay, reasonably okay, I think. Actually, that's why sometime I write in the beginning only, because these things, if I take more time, will waste the time in the class. Okay, now, if not fully correct now, okay, reasonably okay. If I do a tangent here, it should be 0 slope. See, I am not happy actually this one. See. Okay, now reasonably okay. See, or see. Okay, now okay. See, it's common tangent. Parabola of third degree, it will go up and come down. This is the maximum value. Okay, now this is the bending moment diagram, positive. I am not writing, this written here, SFD BMD, same statement, you have to write yourself only here. So this question is completely over. Now I will go to last question. Remember, last question you have to work out, because little work for you also. These all I will not write, but I will dictate for you, so that those who find difficulty, they can at least what? They can write listening to the class. Start. Shear post diagram. Go up by 225 here. Sufficient, this much. Go up by 225. From here to here, come down by half into 9 into 90. 225 minus half into 9 into 90 will give you minus 180. So when you reach here, it will be minus 180. See, 225 here, minus 180 somewhere up to here. See, or I'll reduce the 225, okay. 225 is minus 180. Reasonably okay. Minus 180 I'll write here. Then I think I'll have BM problem there. Okay, I'll manage 180. Now, how to join? See here, plus to plus, then change here. From here to here, parabola second degree, here zero slope and here maximum slope. Therefore, what will happen? Zero slope here and see maximum slope here. It will come this way. Now you got a point here, say x. X at x from here. Okay, sorry, I forgot last time. I have to enter the x value. I forgot what I got. No problem. I got the tricks to get that value. I don't require calculation. 240 into 2 divided by bracket 90 by 8 bracket close root answer. That's all. 6.532 meter. See, 6.532 meter. If you know the basic concept, remember, you know how much fast you can do. You don't have to worry about anything. Once you, if you want the knowledge, go through all the classes from beginning, get the knowledge, or then see what level you will reach. So many people don't understand. They think that what this lengthy calculation, why required? If you want short solution solve, you will get it if you understand this lengthy calculation. Simply you won't get it. Like driving, you can fluently drive provided you struggle in the beginning. What? Every distance in the road, you struggle, leave the clutch, vehicle will stall. Now you can drive fluently, but remember the days when you are struggling that way. So directly you can't enter and drive directly in the road with whatever way you want. Struggling is required. Then see, now from here to here, again come down by half into 3 into 90. But now remember now, maximum slope, zero slope, curvature will change. It will become 315. This is 225. 315 will come somewhere up to here. See, same way it will change. See now, but when you reach here, slope is 0. That was equally important. See, or okay, I'll make it clear now. See, yes. Now here when you reach, slope should be 0. This is 315. Reasonably okay scale. 315. Now this x you have to locate. Okay, this is plus. This is minus. Okay, now here common tangent. See, let the point x be from here. See, those who want to understand intensity at x. One more diagram you write there. Write the free body of this. Write the sketch this side, ignoring that side. W suffix x at x here. 90 by 9 into x is the intensity. Shear force equal to plus 225 minus that second diagram. Half into x into 90 by 9x is a shear force equal to 0. Your x will come. I will tell you what x will come. 225 into 2 divided by 10 equal to root answer. 6.7082 meter. Forgot it. 6.7082 meter. That's all my remembering capacity. I will once again forget now if I don't write fast. Calculate the value. Now, using this value, get the intensity there. Wait, it is 10 times. 67.082 is the intensity there. If you want intensity there, it is 67.082. Remember. Okay, now, BM calculation. BM at A 0, BM at B 0, BM at C. If you look this side, plus 225 into 9 minus half into 9 into 90 into 1/3 of 9, or if you look that side, 315 into 3 minus half into 3 into 90 into 1/3 of 3, whichever way you want to calculate. 225 into 9 minus half into 9 into 90 into 9 by 3. 810 is the BM here. See, available space I will manage. Here ordinate is 810. Now, you also require ordinate here. That ordinate equal to, look this side, plus 225 into 6.7082. Refer that second diagram. Minus half into 6.7082 into the intensity is 67.082 into 6.7082 divided by 3 will give you 1006.231. 10, I think somewhere here, see, 1006.231 is the maximum. I forgot, I told already. See, here slope 0 I told. That is the maximum BM here at the point X, this point. Okay, now join. C to B, parabola of parallel degree, join this way. Here to here, same tangent should continue. It should reach peak value and come back to 0 here. So it will be. Okay, this time I don't know. See, somewhat reasonably, beautifully came. Beautifully it came now. Okay. This is the bending moment diagram, positive. Okay, nothing further. Okay, now, anything, sign sometime. Okay, 1 over plus minus, everything is over. I made all the concept clear. In case of, see, small point. Okay, see, still I am not happy. Okay, now okay. Now, one very important concept, those who want. Here, it is this way. Maximum center, maximum BM came 108, so both reaction came 270. Here, more load this side, less load this side. So, loaded length is more this side, but load is more severe this side. So, this reaction came more, this reaction came lesser, vice versa there. And bending moment maximum came this side. Why? More length is there here. Here bending moment maximum came this side. And one more thing, both these maximum BMs are less than this BM. Why? Maximum BM will come when symmetrically loaded for this case. Because of the symmetry gone, BM will slightly reduce. See, from 1080, it reduced to 1045, 1006. Here, see, 8 and 4 means maximum is near to center than 9 and 3. So this is critical than that one. This is the most critical because why? Both sides maximum at center. You can make this observation if you want. Left to your choice. Okay, now I think everything is over now. Go through this all the 3 questions, practice and get ready for next class. More questions will come. What is the questions? I will decide next time. Okay. Thank you. We'll meet in class number 96.